hopefully by now you have the solutions mixed up. If you don't have the solutions mixed up, there's more than enough. You can probably get solutions for other people in the room. Okay, you can just go around and like, can I borrow some solutions, please? Okay, right? You want to sit there and like hold up a sign like we'll work for solutions or something like that. That's fine. Okay, maybe right as the people walk in, you sit there and hold up a sign like, "Hey, down on my luck, can you spare a solution?" Whatever. Or if you're really hardcore and you want to mix up your own thing. So let me explain what's going to happen. So there's three different parts to this reaction, okay, or to this lab. So the first part, now listen to me very, 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 very carefully, okay? You are not mixing up the entire quantities of these solutions. You are only mixing up about 4 milliliters of each, and even the 4 is just kind of sketchy. It just has to be equal volume, something around 4, okay? Notice I didn't say 4.000. It just has to be the same. Even if you just wanted to do a little trick where you take a test tube and you measure out 4 milliliters of water in a graduated cylinder, and you pour that in the test tube and you make a mark on the test tube, hey, that's close enough for a measurement of 4 milliliters. Okay? You don't have to actually measure out 4 exactly every time. Like, because we're this is chemistry. It just has to be the same volume. Okay? It just has to be the same volume. So what you're going to do, you're going to mix magnesium nitrate, potassium hydroxide, zinc nitrate, potassium hydroxide, and cobalt-2 nitrate and sodium carbonate. So those are the three that they're going to mix together, equal volume. So what I want, and it says in big bold letters to be handed in, the calculation showing the preparation of the 5 solutions. Okay, that's what you all did yesterday. Okay, neatly done. Here's what's going to be the first part of your lab write-up. Are these calculations? Answers on the left?
Yes. Work on the right.
Work on the right. Okay, I should be able to just go down. Boom, there's the 5 masses that you had. First thing you do. Second, balance and the net ionic equations for each of the 3 trials. Okay, so next part, boom, you're going to have, magnesium nitrate, MgNO3 and KOH. Okay, boom, what you get out of that? Obviously, one of those should hopefully make a precipitate. Okay, which one is not going to make the precipitate?
Potassium nitrate.
Yeah, potassium nitrate. You are going to get potassium nitrate out of this?
It don't matter.
Well, it does. Life choice. Okay? It matters in the sense that, yes, is it present? It doesn't matter in terms of making a precipitate. Okay? There you go. So, you're going to have this, then you have the net ionic equation. What 2 things does the net ionic equation have to balance on?
Charge and number of atoms.
What?
Charge and number of particles.
Charge and number of particles. Okay? Number of atoms, charge. Both sides have to balance. Keep in mind, this is going to be a net ionic. Guess what? Some of these should have charges on them because they're existing as particles in the solution. So you're going to have 3 equations, 3 normal equations, and you're going to have underneath there the 3 net ionics. Okay. Then, calculation of the QSP for the reactions. So here's, like for example, this one, not to ruin the surprise, but your precipitate is going to be magnesium hydroxide. So that's going to be the concentration of the magnesium ions times the concentration of the hydroxide ions. But what do you have to do to the concentration of the hydroxide ions? Square that. Now, this is not the concentration that you mixed it up at. Okay? This is the concentration after you have mixed these together. Okay? Listen to me. It is not the original concentration. It's after you've mixed them together. Now, conveniently, because you're going to mix, say, 4 milliliters and 4 milliliters, and you're going to put that together, okay, what's going to happen to the total volume?
It doubled.
It doubles. So what's going to happen to the concentration?
Double.
Yeah. Half.
Yeah, concentration.
Yeah, because you're going to double the volume, right? So very simply, like on that with that magnesium nitrate, the concentration of your magnesium ions after you mix it is just going to be 0.03 because you're doubling the volume. That's why I said it really doesn't make any difference what the volume is as long as it's the same. Now, if that flips you out into the I need to do the math. Okay, if you really wanted to, you could take the 0.06 molar magnesium nitrate and you could multiply that by 4 to get the number of millimoles. If you're really hardcore, you could get the number of millimoles. Then you could divide that by the total volume after you mix it, and you're going to divide that by 8 millimoles. Guess what's going to happen to the concentration? It's still going to be half. This is just more of the mathematical basis to prove it. So you're going to calculate the 3 Qsp values. Okay? Then, here's the next thing that's going to happen. You're going to, once these are mixed, you're going to mix them in one big test tube or a beaker, however you want to mix these up. Then you're going to measure the pH. Okay, so here's the sequence. You're going to mix them together. Okay, obviously a precipitate. Then you're going to measure the pH. Then what you're going to do is you're going to take 1 molar hydrochloric acid, and you're going to add 1 molar hydrochloric acid, 1 drop at a time, and then you're going to stir it. Add another drop, stir it. And you're going to do that until it goes clear. Okay? So you can have a precipitate, add hydrochloric acid, stir, add hydrochloric acid, stir. Basically until it looks clear. Okay? It might not be colorless, but it should be clear. Light should be able to pass through. So what you're going to keep track of on this chart, okay, the observation after you mix them together. Okay, did you make a precipitate? Was it a light precipitate? Was it a heavy precipitate? Well, what's the color of the precipitate? Okay, it doesn't have to be a 5-paragraph essay. I don't want to care how it made you feel. Oh, it made me feel sad. No, okay, just describe the precipitate. The initial pH, okay, boom. Then you're going to add hydrochloric acid until it dissolves. Then you're going to measure the pH after it dissolves. And then you're going to record the number of drops of hydrochloric acid. Okay? 1, 2, 3. Now, y'all are in AP chemistry. I do not want this to look like a 3rd grader at Mays Elementary drew this thing. Okay? No, I want to be impressed. Okay? If you really want to get fancy and set up a spreadsheet and type it on your laptop, that's cool too. But if you're going to draw it out, at least make it look nice. Okay, so here's part 2. You're going to take now 1 milliliter of zinc nitrate and 1 milliliter of sodium carbonate. Okay? And you're going to put that into a test tube. And then you're going to take another test tube and you're going to put 1 milliliter of zinc nitrate, 1 milliliter of sodium carbonate. So imagine that you have 2 different test tubes, each containing 1 milliliter of zinc nitrate, 1 milliliter of sodium carbonate. Okay? Now, once you get those done, you're going to put them in the centrifuge. Okay, so I'll show you. The centrifuge is over there. Basically, you put it in and you turn it on and it makes it spin really, really fast. You create centrifugal acceleration. You create a false gravitational field and it pulls the precipitate down. If you're doing the centrifuge, make sure that you have a balance to it. Okay, make sure that you have equal weighted test tubes on both sides opposite of each other. So you spin it up, boom. You don't have to let it run very long. Get it to full speed, let it run about 30 seconds, and shut it off. That's all you have to do. You don't need to let it run for an hour. You're just going to separate this out. Then, once it's centrifuged, you're going to take a pipette, and you're going to remove the liquid. Okay? You're going to leave the precipitate behind. So when you get done, that test tube should have the precipitate at the bottom with that liquid up above. You're going to take a pipette, and you're going to remove the liquid. Leave the precipitate. Okay? Just going to try and remove the liquid that's up above it. Right? So you're going to do that to both of these. So both of these, after you centrifuge them, you're going to remove the liquid. Boom. Just the precipitate at the bottom. To one of those, you're going to add water. Drop by drop. Don't stir it. You see what happens. The other one, you're going to add 1 more hydrochloric acid. Drop by drop by drop. Okay? You can give it a little bit of a shake, okay, but don't vigorously stir it. And what you want to do is observe the difference between what happens to the amount of precipitate. Okay? Now, I say add about 30 drops. That varies depending upon the size of the drops of water and stuff like that. about 30. But basically, you want to add that until you see a noticeable difference. So Will Stanley would be adding water to his. Nathan would be adding hydrochloric acid to his. So you're going to do this side by side. You're going to do side-by-side comparison. Water, hydrochloric acid. And you're going to see what happens to the amount of the precipitate. Okay, that's part 2. Then on part 2, here's the chart that you're going to have. Initial conditions, final conditions. Okay, initial conditions probably are going to be, hey, they both have the same amount of precipitate, hopefully. Second part is going to be what's going to happen to the one that you've added water to, what's going to happen to the one to which you've added hydrochloric acid. Okay, then you got some questions to answer. Now, part 3. Part 3. Now, in big bold letters, I tell you, we're going to shift this. Now we're going to use 1 molar sodium hydroxide and 1 molar magnesium nitrate. Those bottles are going to be on your lab station. Okay? They're going to be right there, the little clear dropper bottle. Okay? Those are on your lab table. Okay? Don't use the ones we mixed. This, boom, magnesium nitrate, 1 molar. This is important. You use that. So then you're going to mix that up, and then you're going to add 5 drops of each, and then you're going to add 30 milliliters or 30 drops of distilled water. You're going to see what happens to the precipitate. Okay? Now, after you get down with that part, then you're going to centrifuge it. Now, when you do the first centrifuge, you're going to have a test tube to balance that out. We're going to have 2 test tubes that are the same thing. With this one, you're not. So what you want to do, if you don't have somebody else that's ready to centrifuge, what you can do is do what's called a water blank. So this is the one that's going to have the chemicals in it. Then you get another test tube of the same size, and you just fill it with water so that you have 2 test tubes that have the same volume of solution in it. Okay? That way, when you run the centrifuge, it doesn't go, okay, like God awful racket. Everybody goes, dude, you didn't listen to work yet. You didn't balance the centrifuge. Okay? So if you just have 1 test tube to centrifuge, prepare a water blank, it goes on the opposite side, that creates a balanced situation. Now, when you get to line 3 at the top of page 2, it says gently add a small amount of solid magnesium chloride that is equivalent to the end of a match head. So, in other words, about like imagine that little bit right there above my thumb, okay, of that pen. That's all you want to add. So you're going to get your scoop, you're going to take a tiny bit of that, and you're going to add that to it. Now, most of the time this works, but sometimes it doesn't. I'm going to give you a bias. What should happen is that when you add that magnesium chloride to the solution, you should see more precipitate form. Because what you've done is that you've like overloaded it. That would be like me walking in here and all of a sudden the door opens up and 10 extra kids come running in here. And I'm already at equilibrium and 10 extra kids run in here. It's like, whoa, stop! You all just need to sit down, okay? Because I can't handle you. That's basically what should happen when you add the magnesium chloride. You're going to add some additional magnesium ions. It's going to already be in equilibrium. Mother Nature goes, I can't cope with this right now. You all need to sit down, okay? That's what's going to happen there. Then you've got some questions to answer. When you get to question number 2, make a sketch showing the system before the hydrochloric acid and then showing the precipitate in the solution portion. So here's what I'm looking for on number 2. This is referring to adding the hydrochloric acid to the first 3 reactions. So basically what happens is this. You have a precipitate. You have water. You have ions that are floating around up here. Okay? This is just what we call a particle view. Okay? This is basically how you represent what's taking place. I don't care which one you do. Let's say you do the magnesium hydroxide. Okay, hey, I've got some magnesium ions. I've got some hydroxide ions. Okay? You don't have to draw all of them, obviously, because that would take a long time. And then down here you have solid magnesium hydroxide. Now, you're going to add hydrochloric acid. Are you going to worry about, when you add the hydrochloric acid, are you going to worry about the chlorine? No, it's not part of the story. You're going to add hydronium ions. What are the hydronium ions going to react with? React with the water. Or to create water, you're going to act with that. So what's going to happen to the concentration of the hydroxide ion? Gonna go down. So where does Mother Nature get
Okay.
from the precipitate bank? So the second diagram, where you can get a little creative, you can go, oh, here's the precipitate bank. We're gonna make a withdrawal from the bank to replenish the magnesium ions and the hydroxide ions that are being consumed by this. So basically what you're trying to convince me on these two drawings is that you understand the impact that adding the hydronium ions has on the solution. Okay, I'm done. Drawing number 3. Yes, I would like this tomorrow. So we're going to review tomorrow. The test is on Monday. If that's going to throw you into a bind, you can hand the lab in on Monday. But you really have to understand this lab. Okay.